Hi everyone. Today we are going to discuss about a new topic, that is turning effect of forces. The turning effect of forces we can find in our daily life. So let's check it out, this turning effect of forces. So before going to that, today objectives are moment of force, relation between perpendicular distance to applied force, and equilibrium of forces. So before going to this one, we have to learn one word, that is pivot. Pivot is the fixed point about which the door will turn. The pivot is the fixed point. You have to remember this one. So what is the fixed point here? For example, in our daily life we want to tighten a nut here. So we can use this wrench. So here this is called pivot, the fixed point, and the turning effect of force is here. So force is applied here and turning effect of force by this. So what is movement? Come to this word. Movement is the quantity that tells us the turning effect of a force about a pivot is called movement. For example, this is the top view of door. So in this top view of door, you can observe easily this is the hinge, nothing but the pivot. So in this mechanism, you can observe here that if you apply easy force to open and close the door, but it is very hard to apply force to close and open the door. Why it's happening? Why don't we have the force or why don't we have handle of the door here in middle of the door to open and close? Why should we have always handle is here? Because the turning effect of force. So let's check it out another example. In this seesaw game, here the pivot is the middle point. This is the pivot. Here two kind of movements you can observe. Here one movement is clockwise, another movement is anti-clockwise. So here two movements are up here. The definition of moment of force, the turning effect of a force about a point is called moment of force. So how can we understand this? Let's check it out. For example, to lift a heavy box, we can use one lever type material or one rod. To apply this little bit of force here, we can lift this box easily. So we can do these things in our daily life. Did you observe? Yes. With one pivot, with the help of one pivot, the pivot may be rock or wooden block. So with this help of pivot, we can lift this heavy box. So how it's happening? The formula behind this moment is equal to force times perpendicular distance. So what is this perpendicular distance? Perpendicular distance means the distance between the pivot and here the applied force. So this is the perpendicular distance. So force is applied here, this is F, and D is the perpendicular distance from the pivot to the force. So how can we write in the formula? M is equal F times D. And what are the units of moment? Units of moment is Newton meter, because force indicate newtons and D is distance, that's why meters. So Newton meters are the units of moment of force. So how can we remember this formula to find in the terms of force, in the terms of distance? So this is the beautiful triangle you can remember. For example, in this triangle, the upper part is moment and left side is force and right side is distance. If you want to calculate moment, so close this moment, then you can find force times D, distance. You can find this formula. If you want to calculate force, then close this force and remaining thing is moment and divided by distance. If you want to calculate distance, then close this distance. The remaining quantities are moment divided by force. So in this way you can calculate in terms of force, in terms of distance, and as usually moment of force. Look at this picture. Here this is the pivot, this rock, and here two forces are balanced here. So how it is happening? Same moment of force. So here this system is called in equilibrium. So let's check it out. What is equilibrium of forces? So what is the equilibrium forces means whatever may be the anti-clockwise moment of force is equal to clockwise moment of force. Means if some force is applied in anti-clockwise is equal to clockwise moment of force. That means the moments are equal in equilibrium. For example, M1 and M2 are the moments of force in anti-clockwise and clockwise moments. This is going to be equal because if I substitute the values F1 D1, that is force 1 distance 1 in anti-clockwise moment, and force 2 distance 2 in clockwise moment of force, these are equal always if this system is in equilibrium. So let's check it out this example. Person A and person B are different with their weights. So here you can observe person B applied 500 newtons and he is far from the pivot to the sitting position, that is 2 meters, and person A is applying 1000 newtons and he is far away from pivot is 1 meter. So how this system is going to be equilibrium? Let's check it out. So according to the formula, force 1 D1, the force 1 is 500 newtons and D1 is 2 meters. Here force 2 is 1000 newtons and D2 is 1 meter. So according to the formula, substitute these values, you can find the equilibrium of forces. So how it's going to be? So let's check it out according to this formula. I am substituting these values. 500 newtons times here 2 meters is equal to here 1000 newtons times 1 meter. So this is also 1000 Newton meter. This is equal to 1000 Newton meter. So this is the example that this system is going to be equilibrium. This example problem for you. Let's check it out. What is the moment of force here when we are applying 4 masses which are 10 kg each and the distance from the pivot is 25 meter, then what is the moment of force? I hope you understand this concept. If you find answer, please give your answer in comment section. Thank you for watching.